tons of places, some of which might actually surprise you. Because what if I told you that some of your favorite media, sports, and entertainment broadcasts are actually powered by Kotlin too? That's right. Today we're sitting down with Denis Borisevich from RIEDEL Communications to talk about how they've adopted Kotlin in their software stack as a major provider of live production and broadcasting tools. This is Talking Kotlin. I'm your host, Sebastian Aigner, and I'm joined by my lovely co-host, Márton Braun. Hey, Márton.
Hey, how you doing?
I'm excellent. I'm so looking forward to this conversation. So, hi, Denis. Welcome to the show. How are you doing?
Hi. Thanks for having me. Yeah, I'm doing fine. Yeah, everything is nice.
Great, wonderful. Do you want to give a brief introduction about yourself and also about RIEDEL, what it is that you folks are doing?
Yeah, sure. So I'm a software engineer, like senior software engineer in this company, and I'm been in the industry since quite some time already, like more than 10 years. I'm mostly doing like firmware stuff like C++ and C. And then I was converted actually to use Kotlin in this company. And now I mostly use Kotlin in my daily basis, like in my work projects. Yeah. So as for our company, yes, it's called RIEDEL Communications, and it's a German-based company that does video production, broadcasting, intercom, and stuff like this, like for video studios. And we do like the full cycle of production. So basically, we develop our own devices from ground up. And then, the firmware for these devices, then the software, end user software, and we also help organizations like to work with our equipment, with our software. So we have lots of engineers that are all the time like on site, helping people to bring the live events to our customers, to our viewers. Yeah.
I think we'll have a bunch of questions about how this hardware and software and the different components work together. But just as a teaser here, can you share some of the companies, some of the types of events that are powered by these solutions?
Yeah, sure. So like Eurovision Song Contest, for example. They use our equipment there. Then, Formula One, for example, they also use our equipment, our tools to have communication between the team and internally. I don't know, major TV providers like in Germany or in Europe, then European Football League, then the American Football League, also lots of stuff. Yeah, the referees, for example, they use our intercom devices called Bolero, and to communicate with each other and with the team, the production team. Yeah.
Wow. So that's very interesting because you mentioned now a couple of different parts. You mentioned that there's you do broadcast equipment. Now you've also mentioned that there's intercoms. I'm very curious where it is that Kotlin fits into this overall web or architecture of things. So can you maybe give us like a little bit of a lay of the land of what places Kotlin inhabits in all of this?
Yeah, sure. Well, as for I will speak mostly about our project that we do, our product actually. It's called MediaNet, and this is our custom protocol, custom network based on fiber optics to route and transfer audio and video, uncompressed video signals between the devices, from camera, for example, through the network to the the booth where the editor sits, and then we give it out to broadcasters to broadcasting somewhere further. So basically, in our so like in now we have like with this DDM portfolio we have like two major projects, basically the old one, the classic one that we like we call it, and there we use Kotlin mostly as a desktop application to develop the desktop application to control the devices, to set the devices up, and yeah, so this stuff like more or less controlling and setting everything up, to monitor also, yeah, of course. And as for our current project, so that was like a step further from our classic variation. We also added a server part between the device and this user control applications. And well, basically, Kotlin does all this business logic about like routing the signals to build the routes, basically, then to configure the devices, to get all the telemetry from it. Yeah, so like data bank communication, then the user communication, and then of course like our desktop application that we use to control and to set up the whole basically network. So yeah.
Can you explain? This is very exciting. Like it really does seem like it plays a somewhat critical role. Like the data might not be flowing directly through it, but it's certainly responsible for how the data flows, and where it goes. So can you maybe just expand a little bit more on, like, just for my intuition, what some things are that I can configure through this like Kotlin like desktop application or the server application, just to make it a little bit more tangible for me.
Yeah. So, well, maybe I will start a little bit like from like how this how everything looks, because like we have our devices that act as data, like video or audio transmission devices. Like maybe you can say that it's like internet, Ethernet switch, basically, but not for Ethernet, but for video, like based like on the fiber optics and on our own TDM protocol. And so these devices, so the data, the video itself has been like transferred and processed by our FPGA devices. So it's like, well, let's say hardware. So it's configurable hardware, and then so like this heavy loading, like all this number crunching and stuff is, or like the real-time stuff is processed by the hardware, basically. And then we in Kotlin we decide like where the data should flow, basically, which route should the video signal take in our network to have a proper bandwidth, load between the devices, then to have some redundancy, maybe, or robustness when the device fails. We can't, so it's live production, we can't lose the signal, so we have to reroute it right away and through other devices. Yeah.
I have a question about this. Like what, how often are these decisions like being made by the system, and like what time scales are we talking about here?
So normally these decisions should take place only when we configure the system. But well, accidents, they do happen. It can be that the fiber cable is cut or plugged out, or well, the hardware fails. I don't know, something can happen. So we have to have like these several layers of robustness, basically, and redundancy. And so then if something like this happens, yeah, we have to act basically like in milliseconds to try to correct the yeah. Well, I mean, when we work like with the user setting stuff up. Of course, it doesn't matter if we do it like in seconds, because it just, it's user interaction, and people, human beings, are not that fast. When everything is running well, we have to be very, very fast to react on this.
Wow. So where in the system is it actually like that the Kotlin code runs then? Is there like a dedicated box on site? Are you like communicating with the cloud? Does each device get its own like little JVM agent? Like what's it looking like?
That's actually interesting questions because we did some experimentation recently to try to run the GVM on each device. It's like embedded ARM device, basically, very powerful, but still. Now we decided like it's not yet feasible to do this. Also, like with Grail VM or something, but. Although most of our newer devices are very powerful and they can do this, we have to support also like our old devices that are not that powerful, not capable to run the GVM like without any major adjustments, so to speak, and hacks and so on. So basically our devices, they run Linux and the C++ firmware. Then we have a server as a dedicated box. You can install it like anywhere you want, basically. But so our suggestion is to have like dedicated servers. We can also have a cluster set up for more robustness. So basically, we have like several instances in several separate physical devices running as a cluster. So this is basically all Kotlin code. So server-side Kotlin code. And then on top of that, like yet another layer, we have this application to control and set everything up. This is also Kotlin, desktop-based application. So as it is a GVM thing, we run on Linux, Mac OS, and Windows. Most of our clients use Windows, of course, but we can run on basically any platform. And there, we have like a Kotlin, a little bit of Kotlin kind of backend for business logic and stuff. Then we have like JavaFX for our GUI part. It is actually wrapped in TornadoFX to make it like more easy to use and more Kotlin-y. And sadly, TornadoFX is not supported anymore. It still works for us, and we can also, it was open source project, so we can extend it, and that's not a major problem for us now. But it brings us like this declarativeness, and it's much easier to work with, and also we can use Kotlin like as it's meant to be used, and not like trying to hack around JavaFX. And
Okay, I think we have several questions probably about the tech stack in all of these places. Should we start with the desktop part? Because you just mentioned TornadoFX.
Yeah.
So how is the TornadoFX experience? How did you end up there? Like maybe like what's the Why are you laughing?
Well, because my follow-up question is going to be, and how do you get out of it?
Okay, so I was wondering, like, how did you get there? What did you have historically? You said that like Kotlin adoption was a story. So like, did you also have JavaFX before, or like how did all of that evolve? How does it play together?
Yeah, well, of course, we did not. If we would have started today or like a couple of years ago, maybe we would, of course, try to go with the Compose. But this is like a historical project, so I think it's around 15 years old already. So it was basically JavaFX because Kotlin was not there yet. I started to work on this project 2018, and we started moving to Kotlin from Java. And then we discovered TornadoFX, and basically we moved everything, all the code base from pure Java with JavaFX to Kotlin, TornadoFX, and of course like JavaFX as a GUI backend. Can we say that? Like the framework, yeah.
can you maybe give just a brief like history lesson for people on what TornadoFX actually is? Because I think I remember distinctly it having its hyper moment, but also like looking at the GitHub repository now, not a lot of action anymore. The repository is now archived as well. So yeah, maybe just give a little bit of an overview, because I feel not everybody might be familiar with it at this point.
Yeah, sure. So basically, like in simple words, the TornadoFX is like a wrapper library or like a framework around JavaFX to make it basically declarative, so people can properly declaratively create user interface or GUI interfaces in code instead of XML files. And it's written in Kotlin. Kotlin allows using these like very nice DSLs for that. So you can say also like it's like basically a DSL for JavaFX and Kotlin, something like this direction. So yeah, you can do lots of nice stuff with it, and it's quite easy to use, I would say. And the learning curve is also like not that steep at all. So you just start away, and everything is working perfectly. So yeah, and the thing is like as we were moving gradually from Java to Kotlin, also like Kotlin was I think we started already with Kotlin 1 something, I think. So it was already like a first proper release. And and the other thing, like for us, of course, like we wanted to use some more interesting and easier to use language to go forward with our development. And Kotlin was very, very nice tool to have, because I mean it's the interoperability with Java was just like, I mean, wonderful. So we could, so for any new stuff that we developed, we just used Kotlin right away with TornadoFX, and we were also kind of refactoring all our code base to use Kotlin instead of Java. And actually, when I started learning Kotlin at that period of time, it was like 2018. And my first like major task after I was more or less familiar with Kotlin was to start converting the rest of the project to Kotlin. And that went actually much more smoothly than I thought it would be. And now we don't have Java code at all in our code base. And of course, I mean, nowadays, as TornadoFX is archived and there is no major development on it, of course, we would go with Compose, but it's not that easy to basically, like in a single application with different views, of course, to have Compose and JavaFX so that it will look nicely and so that our customers won't notice anything, basically. And to redo this whole project to Compose, it's a major refactoring, I would say. So it would take us quite some time. So we just, work with this historically, like forward with this desktop application. Yeah.
But so are you?
Sorry, just as a very quick follow-up question here. Are you like looking at ways of maybe like turning it into like slices, or like, like dividing and conquering it, like maybe breaking out certain parts of the application and rebuilding that, or working with interop?
Yeah, we looked at it. I mean, the thing is like, as a developer, of course, we would just jump in and use this new tech and so on. But we're also like a company that, our clients rely on us, and we just can't stop developing new nice features and jump in on refactoring like for a year or so. And yeah, we started to use Compose actually to try it out. And well, there is some code already there that is not, well, this kind of in production, but it's not for our end users. It's mostly for like monitoring and for our internal use. And yeah, it seems that, well, we are looking to maybe to move from the desktop application maybe to the web-based application, or maybe try to combine this, because with the Compose, at least like at this stage, it seems to be feasible, because when I was trying it like a year and a half ago or something like this, it was, well, not ready for me to kind of promote this as a tool for this, well, already established major product. So yeah, but like now it seems like to look like very, very nice that you can basically switch between web and desktop view, and that's, yeah. And it seems that, well, the world is moving kind of in direction into to the web-based applications more and more. Also, like with WebAssembly now, it looks like, yeah, you can do basically anything in your browser. So we are looking into it, and if we will pivot to basically like more web-based stuff, then I guess that we will try to, well, at least like try to move our GUI-based work like to Compose. Yeah, partially, of course, but maybe we would just use some not that heavy duty parts of our desktop apps and implement them like as a web app, for example, and then we'll see how our users like it and how it goes forward, and maybe we'll just move everything to web and to Compose. Yeah.
It's just very nice to see that you are, you're keeping up to date with all the developments, and you're checking out what is new and what is still happening to kind of get the benefits here. Which I think that's a really great just attitude to have.
That's fun based. I mean, yeah, well, we want to have also fun at work. So of course we have to maintain our code base, and as a well, quite an old company, established company, and with our products that we have like on the market for more than 10 years already, it's like, yeah, we just can't just abandon this and start with the new stuff. But yeah, still we want to play around with new kind of cool stuff. So yeah.
Yeah, still that's a really great thing to hear, that Compose is mature enough that it's now worth looking at for desktop and web adoption, even with like such strict requirements and in this sort of environment. I think it's also kind of a lot of praise for the whole TornadoFX story and the Kotlin Java interop, because you mentioned that you did a full migration, like away from Java to Kotlin there. And I assume you also had these requirements a couple years ago, and you had to be like fairly conservative, and you had to like keep moving ahead. And the fact that you've managed to do that migration is also fantastic for anyone looking at doing something like this.
Yeah, the thing is, like the IntelliJ basically helped us a lot on this, because the conversion from the Java code to Kotlin code was, well, I mean, it was 5 years ago, so or like 7. God. So yeah, more than 5 years ago, it already kind of worked quite nicely. Of course, the problem was that we also use like Lombok, for example, and we had to like de-Lombok everything and then convert it, like let IntelliJ try to convert it to Kotlin code. Of course, it was not all the time like idiomatic Kotlin code, and not like everything that I would. I mean, not all the classes looked like I would do them from scratch in Kotlin. But it was good enough, actually. It was working most of the time. It was compiling almost all the time. It was working properly. We had to do some refactoring, to change some stuff that was not converted like correctly or understood correctly by the tooling, but it was again before the AI part, so it was just I mean coming from C++ world, for me it was very, very surprising that it can work like this, and it was just like, wow, cool, I can do this, I can do that, interesting. So and basically, we just did it. Then afterwards, of course, so it was heavily tested, and then we also did afterwards, like when the time permitted, we did more refactoring to basically make it more like Kotlin, and
I really love the de-Lombocking expression. That's also what I was doing in 2018 on a project.
Basically
I'm sure a lot of people can relate to that.
Luckily with Kotlin, you can use just like data classes, and so that was experience, and again, like it shows that it's easy to work with Kotlin, because for me it was like the first year working with it. I didn't know anything about Kotlin. I had some Java experience, but no Kotlin at all, and it just worked. It was very cool.
How's that experience been overall as someone coming from C++? Because I'd reckon the languages are still quite different in their approach. I hang around some C++ developers every once in a while, and they're definitely a slightly different bunch oftentimes.
Yeah. Well, I mean, it's different language, of course, but the thing is, like, you have to use the correct tool, correct language, basically for your domain, because, like, also with Kotlin, for example, I recently was doing a small project where I need to do some bit manipulations when I was normally I wouldn't do this in Kotlin, but I wanted to give it a try. And I had to like basically parse the binary protocol, like the packets that come from the network, and to like get some bits and so on. So you have to work like with 8-bit integer or like 16-bit integer and so on, and like move the stuff like around. I can't say that it was that it went smoothly with Kotlin. It was doable, of course. Well, I mean, I did it, works. But like in C++ or like in C or I know Rust, it would be just easy. So I wouldn't go with Kotlin to the domain that where like C, for example, thrives on. It's just doesn't make any sense. And also like to make I did some GUI development with C++. Well, not like the pure C++, of course. It was Qt framework. It also kind of have like very nice declarative stuff in it and so on. But again, with Kotlin and Tornado, it was easier and nicer.
Yeah, I mean, I think there's just fundamentally for different purposes, different languages are definitely better. I am curious though whether you ended up using the unsigned integer functionality that we introduced as experimental, because that at least makes it slightly better, because just working with only signed types on the JVM adds that extra layer of just confusingness on top of everything.
I used unsigned ints, but the problem was that you don't have the operations to shift left or right with them. And this is kind of so like instead of at least like I mean it was
interesting.
a year ago. So basically for normal integer in Java, you can have like left and right shifts to move like let's say if I want to set a flag like on 7th or so, I can just move it. With uint stuff, I think it was not available, so I had to. But luckily, like we have Kotlin, I could use extension functions to just like emulate this behavior, and it was not something like some heavy load stuff, so it was okay-ish to just like wrap it around. But I was kind of concerned about that. that you can't just easily do this. You had to either convert it to Java type to do the shifts, or like do the division or multiplication. Yeah.
At least for regular shifts, I do know that we have an SHL for like shift left and SHR function that also exists on unsigned integers. But like, admittedly, I think our vocabulary here is still a tiny bit smaller than what you have in like real systems programming languages.
I would
And the
say
other part,
that,
yeah, go ahead.
yeah, I mean, I would say that it's still like not the right tool to do this. So it was
For
just
sure.
like an experiment. Well, it worked. Yeah. So it's not like, yeah, well, Kotlin can't do anything now. No, it's just, yeah, you have to use the right tool for the right domain, basically.
Exactly.
This might also mean that we need to work on the discoverability of these operators, because I think a lot of people are going to have a background of, for example, like C or something very similar for working with operations like these, and we don't have the exact same operators. We have these infix functions instead. So maybe this is a feature request towards the IDE to detect if you're trying to use these weird operators that don't exist in Kotlin, so we can nudge you to using the right things.
Actually, I was trying to find it, and then there was like a discussion thread or like a bug report somewhere, like on JetBrains issue tracker or something, and someone was asking about this, and because he wanted to use unsigned, like, I know, 8-bit integers or something and use this shift operator, and it was not available there. Well, at least it was like around half a year ago, I would say, last time I checked. But I mean, again, it was not that I wanted to dive that deep. I just needed a tool to make. So yeah. So maybe discoverability would be better. Discoverability would be nice to have. Yeah.
Hey, we always love getting some extra issues out of out of chatting with people.
Yeah, one of the best parts. So I think we discussed the desktop stack, unless there's something else that's like super exciting within the, like, I don't know if you use any like libraries that would be like really unexpected in this kind of application or anything like that.
Well, I mean, nothing like unexpected, I would say. That I mean, yeah, we use Arrow, for example, yeah, but it's not like we use it like for desktop. We use it like also on server side, mostly. I would say on server side, because like we tend to do more like the functional programming style of Kotlin. So yeah, and luckily Kotlin also allows you to do this, and yeah, we try to work like with pure functions, no side effects, immutable data, and so on. Yeah.
Okay, I think that takes us very nicely then to the server side. So can you talk a bit about what that application does, what tech stack you're building that on, like what's the like core framework that you're building on top of, and well, then we can also dive into things like why and how you're using Arrow.
Yeah. Well, I mean, it's not like that we use some framework basically to do this. It's just, I would say, like just a normal server stuff without any kind of extra extra framework to help us out here. But yeah, of course, we use some functionality from Kotlin, like well, we used that for our REST interface in our previous project, like yeah, using Ktor with DSL, that you can just yeah easily create endpoints, and it was very nice to have. Yeah.
Okay, so
And
the networking part of it at least is built on
yes.
Ktor.
Yeah. So I mean, networking part that was providing this REST interface, because our communication between the server and the desktop application, and also actually with the end devices, is based on gRPC. So it's, well, we have to be, well, we transfer a lot of data, so we can't just use JSON. Well, we use JSON for some like configuration stuff, and but yeah, for like real-time communication, well, no, it's gRPC both ways, and yeah, well, the thing is like being on this broadcasting market, we also have to support some third-party interfaces that are also like well established on the market. And some of our customers, they don't want to use, for example, like our software to configure the devices of the server. They want to use like their own stuff. Sometimes it's like a physical panel that with some software integrated, and they want to use like all the buttons and sliders and whatnot. So we also provide these third-party interfaces that are sometimes built either with external libraries, or like it can be also like REST-based, for example, like with sending normal, exposing normal endpoints for this. And yeah, actually, Kotlin again comes to the rescue, because we were implementing one of these interfaces, and it was very kind of tedious to do this all like in pure Kotlin. So we just created our own DSL for that, and it was just then like this. So this was also very nice feature to have. Yeah, and well, I mean, if you can call Arrow as a framework, yeah, well, we use Arrow heavily in our code base. Yeah.
I find that very interesting, and I would love for you to talk a little bit more about this. Like, is this like how does this come about? Because it's certainly not the norm. So was there someone who was particularly like enthusiastic about a functional programming approach and kind of like advocated for doing that in Kotlin from the get-go? Like, did you just experiment with it for a while, and did you just see that it improved the quality of how you work with your code? Like, what was the story here? Because this always is quite exciting to me, how people like figure out which direction or which approach works best for them.
Well, as you probably have already noticed, we're not that normal in use of the Kotlin, or like not that. Not like most people use Kotlin like for Android and stuff. So, with the functional programming, so it was one of our colleagues, our former team lead in our team. He is on pension right now, so he's not working with us, sadly, because he is a very very cool guy. I mean, he was like always like on cutting edge of technology, although like he's old. But yeah, he was also like all the time like into this functional programming, like Scala, for example. Also, like we were thinking about like using Scala for in this project instead of Java, like Haskell a little bit also. So, and he was trying to introduce these concepts of the functional programming to the team. Some of us were already kind of familiar with that. Some of us not, but yeah, again, it was kind of naturally flowing inside the project. We did some workshops in the company to kind of expose it even to the wider audience. So not only for our team, but also like for teams in other products. So, and we used Arrow like before the first major release actually, and that's it worked till we had to update. And yeah, there was some major issues, of course, but otherwise, I mean, yeah, lots of interesting stuff there, especially if you work like with the immutable data and like some huge aggregate of classes, like you have to modify some internal part, and you can then use optics, for example, and then of course it takes some time to understand these concepts and to familiarize yourself with the concepts. But then when you see how easy it is to test the code afterwards, to do the unit testing, how it is easier to reason about the code afterwards. So yeah, I mean, everyone was very excited about that. So we moved more and more to like a more functional programming style. But again, luckily, like having Kotlin as a major programming language by us, it was easy to mix these concepts, or like do one of the modules like very, very pure and the other one, well, not so pure. And yeah, so it's again, it kind of enables us to play around with different stuff, and also like for the people that are not maybe that familiar or not that comfortable with using that heavy functional stuff, they can also perform and solve the task like without heavily being involved in that, and that's it works.
It's very, very cool. It's very exciting. Would you say that like our listeners, if they haven't had a look at Arrow yet, that it's like really worth the time investment? Because it sounds like you're a pretty big fan.
Well, it's hard question to answer actually, because I mean, if you have time, if you want to learn something new and cool, yeah, sure. I mean, it's definitely worth it, especially if a person is kind of well inclined like into like mathematics and stuff. So like this, yeah, then you see that, okay, yeah, wow, cool. It's like in math basically. You can just do this and that, and yeah, sometimes it takes a bit of like practice and reading the code, and maybe, well, I would say like mostly doing with something with your hands, and with some guidance, of course, and then it just clicks, and you see that, wow, it's like I'm enlightened now. And yeah, but otherwise, I mean, you can live without it for sure, and like the pure Kotlin also kind of gives you very nice tools to work with the functional style of programming without heavily relying like on some more hardcore libraries. Yeah.
That's a very nicely balanced take. Um, but I do wanna dig just a tiny bit further into the functional story before we move on and maybe zoom out a little further, because you did mention that your colleague also had experiences or also evaluated like Haskell and Scala and so on. So I'm curious if you know, or if you could tell us how it ended up that like Kotlin won out over like what other alternatives might there be, because obviously like it's reasonable to say, okay, like Scala also runs on the JVM, if we are fans of functional programming, might be worth a look. So how'd that story turn out the way it did?
Well, it happened actually just before I started working with this team, but I would say like basically it was one of the selling points was a very, very nice interop with our existing Java code base, and we had to kind of well gradually evolve and like do this naturally, not just starting from scratch. With Scala, it was I think it was, well, it was not that easy to just well, let's say, I mean, the thing is like, it's not like we have some Java libraries and we want to use them in our Kotlin project or like in Scala project. It is that we have, well, let's call it like a monolith, and we add some functionality that has to be also used from Java point. So not only like in this direction, and this, well, with Kotlin it works very nicely. With the Scala, it's, well, not that easy to do. Well, the other thing is, again, well, as I said, well, I was not familiar with Kotlin at all, and it was quite easy to learn for me. So it's also like one of the points that it's, well, we thought, I mean, it was, of course, it was a risky decision to take at that point in which direction we should move, like can go to Scala, go to Kotlin, or like abandon Java completely and to work with something else. But what we did bet on Kotlin, and it appeared to be kind of good decision, and it's easier to find Kotlin programmers also, and we also have experience like having like Java programmer that we just say, okay, yeah, well, we will teach you Kotlin like in a week, and he can start working on the basically start working like on the project right away, and that's not a big deal. So well, some people say that well, Kotlin is just like for babies, it's just like easy to do compared to like Scala, for example. Well, again, it depends on what you do. You just take Arrow and just have some hardcore stuff. So I mean, I like Kotlin about that. So it allows you to do like seeing things like naturally, gradually, easily, and that's it. Yeah. So sorry for interrupting.
No, I was just gonna ask if the 1 week of onboarding for a Java developer already includes Arrow or not.
No.
Yeah, okay, that makes sense. I also really liked the point that you made about interop and how exactly you can introduce Kotlin into an existing Java code base, because it really is a huge help that you don't need to like cleanly separate your Kotlin bits of code and make it like, like one directional, and like architect everything in a way where here's my shared stuff, or well, here's like my Kotlin converted stuff, and then here's my remaining Java code. But you really can like arbitrarily, just like throw a Kotlin file in the middle of a Java package and it will basically continue working. I think that's a really good, really important point to highlight here with the interop and migration story.
Yeah, as I said, it was like one of the major selling points for us to use Kotlin at that time. So yeah, and now we're just having fun. So
yeah, at some point, I think we say this a lot, but like a really good way to sell Kotlin is to just like make people try it, because usually they do have fun experiencing Kotlin, and we don't have to force Kotlin on people, because we can just tell them to try it, and usually they will find that it's a really nice cohesive experience. What I wanted to move on to was a bit about testing, because you've mentioned it multiple times now that it was, of course, really important during these migrations to have tests in place. You also mentioned that Arrow specifically makes it easy to test your code. So could you expand a bit more on that, on like in what way Arrow helps you with testing?
Well, first of all, sometimes, well, you can omit some of the tests basically because, well, you don't have to test for everything basically if you use like functional programming. Of course, like, and again, the other thing is like it's easier to reason about the code. So it's more concise. And again, having no like side effects and so on, it also kind of makes life much easier, especially if you have like multi-threaded or an application where you have like lots of things happening in parallel. And I mean, that's one thing. As for testing, again, like well, I tend even to use Kotlin to test my Java code now. So I just try to test Kotlin and test some Java code. Recently, I was like doing one of the projects, and I just did the testing in Kotlin, and it was much easier. So also like with the mock, for example, it's easy to mock the environment to have some like nicer unit testing. But I mean, the thing is, like I would say, like the most of the testing that goes like with our project is with our dedicated test team. Like they do like mostly functional testing, so not like unit testing, and they have a huge, very complex test suite that they've written themselves to like functionally test everything, like starting with the devices themselves to like up to the end user software.
So does that run in like a real environment with actual physical devices? And
so it's, I mean, the full test round for us is around 2 weeks. So it's because
That's not a unit test, yeah.
yes, yeah. So yeah, unit tests they run like quite, especially compared to that. Yeah, so it's like a couple of minutes, I would say. And yeah, again, so for unit testing, normally we just test some modules and not like this whole system. But for like the testing for the release or something, yeah, well, it takes up to 2 weeks. Mostly automated testing, also like some manual testing. But yeah, they use, well, I mean, we have a lot of devices, lots of generations of devices that have to work together. And we have to test lots of combinations, sometimes even weird combinations of like incoming and outgoing signals. And again, as we work with uncompressed data, uncompressed video signals, it's not that we just can't allow the signal to be kind of modified in some unknown way. Basically, when you use like compression, of course, like it can produce slightly different results, and for us it's like no, we can't. We have to be very very precise in that. So yeah, the proper testing, I would say, is done by our very very good and smart test team. I mean, they do unimaginable things with with our code. So yeah, but yeah, for us, of course, we do testing like just normal unit testing. Yeah, either sometimes it's just purely JUnit like or code test, and sometimes some mock. And yeah.
That's fascinating. The like a 2 week turnaround on real tests like really makes you think twice about committing any changes, especially if it's something exciting for the code base.
Yeah.
But it's really nice to hear that these kinds of things can be part of the stack, like that you can trust, whether it's Arrow, Ktor, JavaFX, like any of these pieces that you have in there, that you can build on these and produce software that will endure this kind of testing.
Yeah, that's the very important point actually. That we have to be 100% sure that everything runs smoothly. So like the testing, also that's why the functional programming and immutability also helps a lot in this regard. And yeah, so we double check, we make everything very very robust. And yeah, luckily we can, like doing this, we can concentrate actually on doing things and not like fighting with the language, with the framework, or with anything. So it just enables us to work smoothly on the task and not just trying to figure out why something is just not working properly, doesn't build, or I don't know. Yeah.
That's really, really great to hear. Genuinely. And I think this was overall a really lovely like excursion into a domain that we typically don't see and don't get to discuss at such length. So thank you very much for that. I am curious about two more points. One of them is do you have any like further plans when it comes to like rolling out Kotlin more inside RIEDEL? And then the other one is what is there anything in the Kotlin language that is still an open wish for you that you would wish would maybe be improved or changed, or a language feature that you are looking forward to, something like that?
In terms of like moving forward, of course, so I would say like most of our backend work is in Kotlin and will continue to be in Kotlin. I would like to have like more exposure to Compose in the next years. We'll see. We'll test it again, and hopefully we can continue our work like with the Compose, because it looks like very very kind of cool, and this multi-platformness is also very very cool. What I would like to see was, so we experimented a little bit with Kotlin native, but not native as an Android and iOS, but to run something like on Linux, like on ARM, like target just a normal Linux distribution. It was a couple of years ago. But I would like to see like improvement in this direction, or like maybe WASM, more WASM improvements, because it's also kind of, for me again, like as a C++, also like a C++ developer, it kind of always very interesting point, because it's not like the normal use, I would say, for that language, but I would happily see some more kind of cool work like this, because like, let's say we want to build, I don't know, some very, very small tool like that's people normally use, I know, Go, for example, Go language for that. I would, some integration, I know, like with GraalVM or something, so that I can produce just a binary that can run without the GVM. That would be, will help me a lot in my work, of course.
Nice, great. I mean, I think there's a lot of developments happening in all those areas. So I hope that we're all looking towards a bright future here in this regard as well. So yeah, thank you so much, Denis, for coming on today. The next time I'm gonna tune into like some like sports or entertainment broadcast, and it works well, I'm just going to go. I'm just going to choose to interpret that as Kotlin doing great work behind the scenes for those like live productions, those live broadcasts, and very exciting. I'm gonna tell everybody the next time I'm tuning into Eurovision, the reason why you see this picture is because of Kotlin in some way or another. So yeah. Thank you very much. Really appreciate all the insights. We dove into so many different parts, and I hope that everybody who listened in at home also thought this was an interesting little excursion. So, thanks again for coming on. Thank you for tuning in. Thank you, Márton, for co-hosting as usual, and we of course hope that we will see all of you in a future episode of Talking Kotlin. Take care, everybody, and see you soon. Bye.
Bye bye. Ciao.
Bye.